Alright, the last thing we're going to talk about, well, no, it's more stoichiometry. We're going to talk about moles and all that good stuff. So, here we go. Go to the stoichiometry conversion chart thing that you guys have. So I can zoom out a little on this. Okay. The way you're going to read this, okay? If you have a mass of some compound, you want to go to moles, okay? You need the molecular weight, okay? This we get from the periodic table, all right? In order to go from moles of a compound to molecules or atoms, you need to use this number here, which is Avogadro's number, okay? We're going to look at the same thing here. So if you have a mass of Y, you need to get to moles of Y, then you need to use a molar mass. Again, we find this on the periodic table. This is your grams per mole. So if we have something like oxygen, okay, if we look on our periodic table, find my periodic table. Where is it? Okay. So I'm going to look over here at oxygen. This says that it's 15.999. So basically this is 16. And remember, when we do this, we're saying that oxygen is 16 grams per mole. Okay? If I'd had O2, I would have said it was 32 grams per mole, because I have two oxygens and there would be 32 grams for every 1 mole of it that you have. Okay? So let me zoom in so you can see that. Where's the zoom in? Okay. Should be able to see that. Alright, so then if I want to go, so that will give me moles, okay? If I have moles of Y, I can convert to moles of X, or I can go to molecules of it, alright? So we'll do a couple of these examples and hopefully it'll make some sense and you guys will kind of come back to remembering what you guys had done previously. Let's look at the first, sorry, I'm yawning. First problem here. Alright, so problem number 1 says, how many grams of 8.1 times 10 to the 22 molecules of sucrose weigh? So, here's our formula for sucrose. C12, H22, O11. I've got 12 carbons. Each carbon has a mass of 12.01 grams per mole. Okay, I know that because if I look over here on my periodic table, I see that this has, let me zoom in so you can see that. Alright, so you should be able to see that. 12.01 grams per mole. Okay. Alright. Hydrogen is 1.01 per mole. We have 22 hydrogens, so this here is going to be by 12. This is going to be multiplied by 22. And again, if we look, here's hydrogen, rounds to 1.01. And last but not least, we have 11 oxygens. Oxygen is 16.0 grams per mole. We have 11 of them, so what values I get here, let me get the calculator. So we've got 12 times 12, which should be, well, 12 times 12.01 should be 144.12, and this is grams per mole. Then we have 1.01 times 22, so we get 22.22 grams per mole. And we have 11 times 16, we get 176 grams per mole. So basically what all these are saying is if I have 1 mole, you know, of 11 oxygens, this would be the mass of it. So I take the total, sorry I'm yawning. If I take the total mass here, we're going to get 144.12 plus 22.22 plus 176 we get a total of 342.34 grams per mole. So if I have 1 mole of C12H22O11, that equals 342.34 grams. Okay? Does that make some sense? Again, this is what we call molar mass. Okay? So that's how we always find the molar mass of any compound. Alright. So that being said, if we look back at the stoichiometry conversion chart, okay? We were given molecules. If we look at this one, we have molecules of sucrose. Okay, let me pull that down. Let me zoom out. Alright, so number 1, if you're reading this, we have 8.1 times 10 to the 21 molecules of sucrose. We need to know what the grams are. So if we look at this chart, if we're given molecules or atoms, we need to go from molecules to moles, and then from moles to mass. So, to set this up, we're going to say that we have 8.1 times 10 to the 21 molecules of C12H22O11. We are going to multiply this by, for every 6.02 times 10 to the 23rd molecules, we have 1 mole of C12H22O11. This right here is Avogadro's number. We know that 1 mole equals 6.02 times 10 to the 23rd. This can be molecules, atoms, particles, so on and so forth. Okay, so the next step. So now what you notice is your molecules, they're going to cancel out. So now we're at moles. We're at this step here. So now if we stopped our conversion factor here, we would be at moles. We need to take it one more step. And so how do we go from moles of a compound to mass? I'll be done in just a second. We know, based on what we calculated earlier, that we have 342 grams for every 1 mole of sucrose. So we have 342 grams, that equals 1 mole. So for every 1 mole of C12H22O11, we have 342 grams of C12H22O11. So now your moles units are going to cancel out, so the only units I'm left with are grams. So now we need to multiply across the top, divide by the bottom. When I put this into my calculator, let me zoom into this. Whoops, gotta zoom out. This is how you need to put this in, and this is the way I always do it. Let me move this up so I can see. Give me 1 second. It's fine? Okay. Alright, so parentheses, 8.1. I always do second E, which is this comma button here, which this E just means times 10 raised to the power. So that's 21. Close parentheses. I'm also going to multiply by 342. That's my value on top. I'm now going to divide by my value on bottom, which is 6.02. Second E to the 23rd. And we get a value of 4.6. Am I writing in? Oh, can't see. Alright, so we get a value of 4.6 grams of C12H22O11. Okay?